So in section 6.7, we're not going to just be playing with quadratic expressions and factoring them and combining like terms. We're actually going to be able to solve quadratic equations using those skills. So here's the argument, and you want to write this down. Basically, if I have a, that almost looks like minus, if I have a times b equals 0, then I have two things that multiply to make 0. Well, then one of them must be 0. Either a is 0 or b is 0. In either situation, the whole equation would equal 0. One must be true. Either a is 0 or b is 0, or both could be 0. This is called the zero product property. Okay? So we're going to use this same logic right here, that two things that multiply to make 0, one of them must be 0, or if one of them is 0, the whole thing becomes 0. And I'm going to look at this, because this is not two things that are being multiplied. X squared plus 5x plus 6 equals 0 is not something where there's two things being multiplied. But it can be. See, we can factor it. If this factors, it will factor into two groups that are being multiplied. First, what makes x squared is x and x. Second, what multiplies to make the 6 combines to make the 5. 1 and 6, 2 and 5. Since they both need to be positive, I'm thinking 1 and 6, 2 and 3. I'm thinking it's the 2 and the 3. Both positive to make the positive 5, both positive to multiply to make the positive 6. So this is factored, it must be factored, set equal to 0. And once it's factored, there's that zero product property again. What makes this 0 is if this first group, if x plus 2 equals 0, then the whole thing would become 0. Or if x plus 3 equals 0. Well, set each group equal to 0 and solve it. If I solve this one on the left, we subtract to get that x is equal to about negative 2. If I subtract the 3 right here, we get that x is equal to a negative 3. That's our solutions, negative 2 and negative 3. See, I can solve this even though there's two x's here, because when I put it into two groups that are being factored, I can figure out what makes each group 0, and those are our solutions for the original equation. You can always check this, and I encourage you to do this. We just said negative 2 is a solution. If x equals negative 2, then I'm going to go up here to the equation, and everywhere there's an x, I'm going to put a negative 2. So x squared becomes negative 2 squared plus 5 times x, negative 2, plus 6. Let's see what this becomes. This should equal 0. This becomes 4 minus 10 plus 6. This gives us 0 equals 0. This is one of our solutions. We also said that negative 3 was a solution. Well, let's check it. Negative 3 squared plus 5 times negative 3 plus 6. Remember, we're putting these numbers in place of all the x's in the equation. So what do we get here? Looks like 9, negative 15, plus 6. Well, that's cool because what? 0 equals 0. These are our two solutions. These are the solutions that work both when it's factored and when I plug it into the original equation. Okay? Alright, let's keep going. The good news is this. This is actually one of the more advanced questions. You're going to see a lot of the homework is going to start off more like this. And you're like, well, that looks scarier than what we just did. Well, not really, because the first step's already done. See, I want it factored and set equal to 0. So that's already done. So what do we do when it's factored and set equal to 0? We take each group, and set them equal to 0. What do I do with this x right here? See, a lot of people just ignore it. And that's not going to work, because what we're going to say here is that one of our solutions, if I set that group equal to 0, that is a solution. X equals 0. If I stick a 0 right here, I get 0 times 1 times negative 7. The whole thing zeroes out. 0 times, I don't really care, but 1 times negative 7, it equals 0. Take the second group and set it equal to 0 and solve it. So we're going to subtract the 1. 5x is equal to negative 1. Divide by 5. And x is equal to negative 1/5. just leave it. Okay. Is it right? Well, let's check. I get negative 1/5 times, well, negative 1/5 times 5 gives us negative 1 plus 1. And over here I have negative 1/5 minus 7. Oh, see, after you said, I told you this looks harder, but look, what happens here in the middle? What is negative 1 plus 1? That becomes a 0. Doesn't matter what anything else is at that point. Because anything times 0, the whole thing zeroes out. Negative 1/5 works. And the last one's not difficult. X minus 7 equals 0. So when I add x equals 7, is it right? Well, I get what? 7 times 35 plus 1, big messy numbers, times 0. All this other stuff doesn't matter. The whole thing zeroes out because that last group. These are our 3 answers. Like I said, the most common mistake, the thing you want to kind of put a star on to remember, is that if you have an x by itself, that is still a solution. You set that group, that x equal to 0 to get that solution. This one is not factored, unfortunately. And what makes me a little sad is I'll have some people look at this and tell me it can't be factored. Or they'll try to put it in 2 groups, or they'll try, and I'm going to say again, you really need the sections 5.1 through, or 6.1 through 6.5 strong on this, so that you know how to factor. The first thing I always look for when I factor is any like terms. 3x, 21, 3 and 21 are both divisible by 3, and these both have a x. When I factor that out, I'm left with x plus 7. This is now factored. Take each group, set it equal to 0. You can treat the 3x like a group if you'd like, or you could do it separately. It makes more sense, I think, to group it. 3x equals 0, and x plus 7 equals 0. The one on the left, don't be scared by that. First of all, do not do this. We should be past this. 3x minus 3. The 3's don't cancel. You cannot cancel multiplication with subtraction. We divide and get that x is 0. And x is negative 7. And what I love about this chapter is we can check it. Look, what is 3 times 0 squared plus 21 times 0? What is 0 plus 0? See, that 0 is one of our solutions. What if I put in a 7? This one's not going to be as pretty. It's going to be 3 times negative 7 squared plus 21 times negative 7. Ooh. 3 times 49 plus, what is that? 140 minus negative 147. 3 times 49 is positive 147 minus 147. We get 0 equals 0. Those are our 2 solutions. On example 4, here's the temptation. This is the common mistake. This is wrong. People go, oh, this is like the other one, and just factor out the x. X minus 8 equals 16, and start just setting groups equal to what? Well, remember, this is wrong because it needed to be set equal to 0, and this is not set equal to 0. So do not do this. You need this set equal to 0 first. You need that 16 to be a 0. We can do that. To undo a negative 16, we add 16. So that we have x squared minus 8x plus 16. Can this be factored? I sure hope so. First, the x squared is x times x. Second, what multiplies to make 16 combines to make an 8. How about 4 and 4? And to make a negative 8, both those 4's would need to be negative. Set each group equal to 0. X minus 4 equals 0. X minus 4 equals 0. That's weird. We get x equals 4. We get x equals 4. This is just called a double solution. We got the solution twice. Our answer is only x equals 4. How do I know that? Well, I could check it. Does x equal 4? What's 4 squared minus 8 times 4? Well, if we're right, it should equal negative 16. What is 16 minus 32? Negative 16 equals negative 16. This is our solution. Next one. You're like, I'm not going to fall for it this time. This is not set equal to 0. Okay, that's fine. Then let's move the 25. So I have 4t squared minus 25 equal to 0. Can this factor? Well, I hope we just got done with the section a couple sections ago of special products. This has two terms, so my notes tell me to look at binomials. This is a squared minus b squared. This is what times itself makes 4t squared. What times itself makes 25. But I need it to combine to make a 0 in the middle. So one of these 5's is positive and one of them is negative. So we have it set equal to 0. We have it factored. Now we take each group and set them equal to 0. For the first one, we subtract the 5, so that 2t equals negative 5. We divide to get negative 5 halves. The second one, we add the 5 to get that 2t is equal to 5. We divide to get positive 5 halves. So t is equal to 5 halves. T is equal to negative 5 halves. By the way, this is not the way I would have solved this. There's nothing wrong with this method, but let me show you something else. See, 4t squared equals 25. This is different than some of the previous ones because we only have one t. That t, I don't have ax squared plus bx plus c. I just have that single t. And if I think about PEMDAS, because we've solved using inverse operations before, that t is being squared. It's an exponent, and it's being multiplied. So if I want to do inverse, we do the opposite and backwards. So we undo the multiplying by dividing. T squared is equal to 25 over 4. And we undo the exponent. We undo a second power with a second root. So that we get t is equal to the square root of 25 is 5. The square root of 4 is 2. But you have to remember, if you want to do it this way, there's nothing wrong with it, but you have to remember that from the square root, we get a plus or a minus. So I still get positive 5 halves and negative 5 halves. If that's confusing to you, don't do that. They're not really intending you to do that at this point. I'm just telling you how I would handle this question. Okay? Last but not least, and I'm going to tell you right now that this is not my favorite example. They're in the homework. They're a bit of a challenge. The issue here is what, again? This is not set equal to 0. But I can't just subtract the 9 over because the left side's all complicated. So what they're going to make you do here is you're going to need to clear out the left side, distribute it out. X times 2x, x times negative 1, 3 times 2x, and 3 times negative 1. Now I can combine the like terms. Negative 1 plus 6 is, I think, positive 5. And now I can set it equal to 0 and get 2x squared plus 5x minus 12 equals 0. This we have solved before. This is where the a is not a 1. So how do I factor this? You're either going to use this diamond or you're going to use the t. But either way, I like to call it a c factoring. What is 2 times negative 12? And our b goes down here is the 5. We're looking for two numbers that multiply to make 24, combine to make 5. If you're not sure, list them out. I see a 5 right here. The 3 would need to be negative. The 8 would need to be positive. I use those two numbers again, just like we had before, to take the middle term and split it. Why do I want 4 terms? To factor by. Factor this out of these two. They have, I think, only an x in common, leaving us with 2x minus 3. The second one, I think they have 8 and 12 is divisible by 4, leaving us with 2x minus 3. This is lovely because these two terms have what in common? And when I factor that out, I'm left with the x plus 4. All this work, like I said, this is a way harder question than I would give you on the test. There are a couple in the homework. Stick around and get some help on these. I expect these to be a little more difficult. This might be one you need a little more help on. I think it's kind of adding punishment where it's not necessary. But anyway, let's go ahead and finish this up. So now that we have our two groups, to solve them, set each one equal to 0. Set each one equal to 0. See, this makes me sad. I will have some people just circle this like it's the answer. That's somebody that didn't finish the homework for this chapter. It's kind of sad. But basically, this is not a solution. To solve, we have to set each of those groups equal to 0. If you stop at this point, I'm going to end up giving you half credit, because you have done all the work, but you have yet to actually solve it. Set each group equal to 0. Start solving. Now we earned another quarter point. And now we earned full credit. There should be two answers, x equals 3 halves, x equals negative 4. And for the last time, could I check that here? Yes. Do I want to plug it into this here? No, probably not. What I would probably do is I would use some technology to plug those in. Just put that in place of the x's and hit enter, and it should be 9. The negative 4, plug it in. But the idea is you could still plug these numbers in. If it's a homework question, go ahead and type it in, hit enter. If it's wrong, rework it. But on the test, the reason I love these questions is you can always check these answers.